Today we're going to look at graphing the trig functions secant, cosecant, and cotangent. We'll do a few examples in class today. First, I want to kind of introduce you to the idea that I'm going to use in class. So how do we graph these things fairly efficiently? Well, the first thing you got to keep in mind is that these are reciprocal trig functions. This is the reciprocal of cosine, this is the reciprocal of sine, and this is the reciprocal of tangent. That keyword reciprocal is going to be very important today, and it'll actually make our graphing a lot easier. So let me kind of illustrate by doing two problems with you. Let's say we wanted to graph the cosecant graph. Well, now let's keep in mind that cosecant is the reciprocal of the sine ratio. One way to do this is let's think about what the sine ratio does. Let's think about the sine graph, and we can maybe use it to create or generate the cosecant graph. So what I've done over here on the left-hand side is I set up a table of values, and the arrows are next. These are the critical values for sine: 0, 90, 180, 270, and 360, because at 0 we get a sort of a midpoint, we get a high point, we get a midpoint, we get a low point, and a midpoint. Those are the 5 critical values for the basic sine wave. And I've also put in their values right here. I've also put in a few sort of intermediate values that are going to be useful for this illustration. And then over here I've set up a little column for cosecant. And that's going to help us make the graph. So again, keep in mind that I want the reciprocal of the sine. So at 0 degrees, I have 0, and you go, well, what's the reciprocal of 0? 1 over 0, which is undefined. Okay, this is undefined. There is no numerical value. Let me zoom in a little bit for that. And so right away, we kind of at 0 degrees, we're undefined, and we have to think about, well, what might that mean? So more on that in a few minutes. Let's go to 90. At 90, the sine ratio is 1. Well, we want the reciprocal, 1 over 1, which is 1. So at 90 degrees, the cosecant is 1. So I'm going to go to 90 degrees, and so the cosecant is resting on the same spot that the sine is resting upon. So, okay, interesting. Not sure what I'm going to do with that, but let's move on. At 180, the sine is 0. Well, 1 over 0, once again, we're undefined. And so this is one of the things that happens with the reciprocal ratios as you run into these undefined situations. Wherever like say, sine is 0, cosecant's going to be undefined. If we were doing the cosine graph, wherever cosine 0, secant's going to be undefined. So you have to be kind of ready for the undefined situations. Let's go to 270, where we have negative 1. 1 over negative 1. The reciprocal of negative 1, of course, is negative 1. So we have 270, and again, negative 1. So once again, we're kind of just sitting right on the sine wave. And then with 360, again, we run into this undefined situation. And so you're going, okay, well, that didn't really seem to help me with the graph. All I got were these sort of two points right here. So that's why I kind of wanted to put a few other intermediate values in here. And so we have to do a little thinking here. And so I've made a little unit circle on the bottom for reference. I'm going to think about 45 degrees. At 45 degrees, which is right here, okay, we happen to have a special right triangle. Okay? And in this case, the height, the sine, okay, is root 2 over 2. Or if you wanted to think about it, root 2 over 2. And so sine 45, root 2 over 2. Which I think is about 0.707, I think. So if I were to go to 45 degrees, about 0.7 something kind of makes sense right there. Well, the cosecant is the reciprocal. It's 2 over root 2. Now you have to think about this a little bit, but if I took 2 and divided it by root 2, I'm going to get root 2. Again, you may have to think a little bit about why that is, but if I took 2, which is the square root of 4, divided by the square root of 2, I'd end up with the square root of 2. Now the square root of 2, let's see what that is. Clear all this. Second root 2 is about 1.414. So I'm going to put a little estimate here, 1.41. And so I'm going to go over to my graph. I'm going to go to 45 degrees, and I'm going to go about 1.4. This is 1.5 is here, so 1.4, maybe right about there. So I've got another point now. So I'm 0, I'm undefined. I've got 1.4, and then at 90 degrees, I've got 1. So then let's go to 135. So let's think about, well, 135 is sitting right here, 135. And so once again, the sine ratio, okay, is the same as it was over here. It's root 2 over 2. So this is root 2 over 2. Well, again, we're gonna flip it over, and you kind of say, well, wait a minute, it's going to go to the same place that 45 degrees is going to go. It's going to be root 2. It's going to be 1.41 again. So when I go to 135, 90, 135 is here. I'm going to go back to 1.4 and place a dot right there. And you're kind of, okay, well, let's kind of keep going on, plot a few more points, and then we'll try to see if we can connect this and make sense of it. So at 225, let's think about what happens to the sine ratio. 225 is here. The sine ratio is negative root 2 over 2. And so negative root 2 over 2. Well, if you flip that over, it's going to be 2 over negative root 2, which works out to be negative root 2. It's just going to be the opposite answer, negative 1.41, that we had gotten before. So at 225 degrees, so let's see, here's 180, 225, if we go down 1.4, we'll have a spot right here. Now remember, we already got one right in here. So I'm starting to see a little bit of a pattern of, okay, dots here and dots. Maybe the next one I think will be over here. Let's try 315. Think about where 315 is, 315 degrees. So this is also going to be negative root 2 over 2 for the sine ratio. So negative root 2 over 2. And then take the reciprocal of that, or flip it over. 2 over negative root 2 is going to be negative root 2, which is negative 1.41. Now in time, you'll find that you'll probably just kind of skip over this step and just kind of carry it in your head, and you'll be able to go kind of straight to this process. And then in a little more time, you'll start to realize, okay, I really don't need to plot all of these points. I have a good sense of the pattern. But until we get that sense of what the pattern is, we have to pretty much plug in points for a while. So just give it time. So let's see. So at 315, I had negative 1.4 as I suspected I would. And so now we got to try and figure out what's going on here. Well, it turns out the undefined situations are really just going to be asymptotes. Okay? So what I'm going to do at 0 degrees, I'm going to undefine, I'm going to put an asymptote right here. And let's see, where else was I undefined? At 180, things were undefined. So I'll put an asymptote there. And then also at 360, I have an asymptote. And I'll put that asymptote right at 360. So in essence, wherever the sine ratio is 0, the cosecant ratio is going to be undefined. There's going to be an asymptote in the graph. And then you're going, okay, well, what's going on between the asymptotes? Well, you end up with a shape that looks something like this, like kind of a U shape. And I'll try to justify that in just a second here. Not quite a parabola, but if you want to think of it as like kind of parabola-like, that's okay. And then here you'll have one that's kind of opening downward. And this is one complete cycle of the cosecant function. You have kind of one curve going up and one curve going down. Well, now let's try to connect a few other ideas. Okay? So basically what you have here is the sine ratio. The highest the sine is at 1. And then the sine ratio starts dropping, starts getting smaller. So you've got smaller and smaller fractions. Smaller and smaller fractions. So for example, right around here, that might be 1/2. And you say, well, what's the reciprocal of 1/2? Well, the reciprocal of 1/2 is about a 2. I get down to maybe 1/4. Well, the reciprocal is 4. So the lower this gets, okay, the higher its reciprocal is going to get. And same thing's happening over here. The lower the sine is getting, well, the reciprocal is going to have to grow. And again, that idea of, okay, well, the height right here is about 1/2. So then if I take the reciprocal, the height should be about a 2. Okay, right? Whoop, there's about 2. So my graph's a little bit off right here. And the same is happening over here. The closer this gets to 0, that means the smaller its fraction is getting, the more extreme, okay, the reciprocal is going to get. So it kind of opens away from the sine wave. And so as sine gets closer to 0, okay, the reciprocal is going to have to get further away from 0. Okay, so again, this is the cosecant wave. Okay, just like the sine wave, it has a period of 360 degrees. It takes 360 degrees to go through a complete kind of up cycle and down cycle. If we were to continue, the next one would be another up cycle over here, and this would be part of a down cycle if I went over here. So what do we try to glean from all this is, well, wherever sine is 0, that's where the asymptotes of cosecant will be. Okay? And wherever the sine kind of peaks, okay, that's where we're going to have kind of one of these little up U's. And then wherever sine reaches its bottom, the cosecant, that's where it's going to have one of its sort of down U's. And so there is the cosecant. You would do the secant graph in much the same way, except you would use cosine and build upon the cosine. Okay, so that's a little bit on the cosecant. Now let's try one other one. Let's try the cotangent, okay, going through a similar kind of set of steps. So again, I've kind of created the tangent. I've drawn the tangent graph right here. I've put in the critical values, that's what the arrows are for, and I've also thrown in a few intermediate values for the tangent ratio that'll help us, because we're going to try to do reciprocals again to see what the cotangent graph looks like. Okay, so let's get started. So at 0 degrees, the tangent is 0. Well, the reciprocal of 0 is undefined. And so I think you probably figured out that, okay, so that's where another asymptote is going to be placed on the cotangent. And we'll do that in a few minutes. So then I'll go to 1. Reciprocal 1 over 1 is 1. Undefined. Now this is interesting. Undefined, okay? Why is tangent undefined at 90 degrees? Okay, let's think about 90 degrees. At 90 degrees, okay, we've got lots of height, but we have no horizontal displacement. We have lots of height, okay? Often say the height is 1, and then horizontally we've got nothing, and that's why it's undefined. Well, if we're doing the reciprocal, okay, for cotangent, okay, we would flip this over, and we would now have 0 over 1. So 0 over 1, which is 0. And so you get this nice little relationship here is, well, where one function is 0, the reciprocal is going to be undefined. And vice versa, where the function is undefined, the reciprocal is going to be 0. And again, think about that for a while, and you'll be able to make sense of it. Moving down here, 1, the reciprocal is 1 over negative 1. It's negative 1. And then the reciprocal of 0, 1 over 0, which is undefined. Okay, so as we've kind of figured out from before, we kind of know what the undefined pieces are. Those are going to be asymptotes. So at 0 degrees, I'm going to place an asymptote. And at, let's see, at 180 degrees, I'm going to place another asymptote. So I've kind of got asymptotes running here, kind of in between. So wherever the tangent function is 0, that's where the cotangent function is going to have its asymptotes. And then I'm going to plot these other points here. So at 45 degrees, I have 1, just like I do. So tangent and cotangent are exactly the same at 45 degrees, which kind of makes sense. If you think about where 45 degrees is, 45 degrees right here, the vertical and the horizontal are exactly the same. So whether I put this one over this one, which is tangent, or I put this one over this one, which is cotangent, they're going to be a 1-to-1 ratio either way. So that actually, when you think about it, is not too surprising. So I got a 1. At 90 degrees, I've got a 0. So I have a point here. And at 135, I've got a negative 1. So I've got these 3 dots here, and then I've got these asymptotes here. Maybe I've got something that's kind of curving or going this way. Well, let's plug in a few intermediate values and see if that in fact is the trend. Okay, at 30 degrees. So 30 degrees, again, is a special triangle. And at 30 degrees, so let me kind of make myself a 30, 60, 90 triangle. Let's see, I remember that this is 1, the hypotenuse is 2, and the long leg is 3. So if I was going to use that, I would say, so the tangent ratio would be 1 over root 3. 1 over root 3. That's what tangent of 30 degrees is, 1 over root 3. Well, if I took the reciprocal of that, that would be root 3 over 1, which of course is just root 3, which as a decimal, let's see what that is. I want to say 1.7, but better safe than sorry. 1.732. So about 1.73. So if I were to go to 30 degrees, which would be right here on my graph, I would go up to about 1.73, 1.73, so maybe about there-ish for 30 degrees. So now, okay, that's kind of good. It seems to kind of fit this trend here that I'm seeing in my points. Let's try a few others. I also picked 60 degrees as an intermediate value. Now 60 degrees, again, that's a special triangle, so I'm going to think about, here I am in this case, and so once again I've got a 1, 2, and a root 3, and so the tangent ratio is root 3 to 1. So for 60 degrees, the tangent ratio is root 3 to 1. So that means if I were to do a reciprocal, okay, the reciprocal would be 1 over root 3. Interesting, it's kind of got reciprocals and other reciprocals of reciprocals in here. And so 1 over root 3, let's see what that is. 1 divided by root 3, about 0.577, I'll call it 0.58. So if I were to go over to my graph and say, well, at 60 degrees, 30, 60 degrees, I'm at 0.58, here's 0.58, so maybe 0.58, maybe right about there. And so again, it's continuing to follow this little trend here. So I'm feeling like my next set of answers are going to kind of hopefully come down here. So let's go through and confirm that. At 120, which is right there's 120. Once again, I got another 30, 60, 90 triangle. And so my tangent, let's see, it's the 1, 2, root 3. So it's another root 3 to negative 1. That's a root 3 to negative 1 relationship. So root 3 to negative 1, which I flip that over, it's going to be negative 1 over root 3. So it's going to be negative 0.58. So we're seeing some good symmetry in these answers. So let's see, at 120, so 90, 120, we'll go to negative 0.58, right around there. Again, I'm really liking what's developing here. And then finally, let's go to 150. 150 is over here. And so again, a 30, 60, 90 triangle, just oriented a little differently. So this would be 1, 2, and then root 3 along here. So I've got a 1 over negative root 3 relationship. So 1 over negative root 3. So if I take the reciprocal, flip that over, negative root 3 over 1, or negative root 3, or as a decimal, negative 1.73. So I go over to here to, let's see, 150, and then down to 1.73. And so now it's starting to become apparent what I'm looking at is this graph right here is kind of almost like kind of a mirror image or a reflection of the tangent graph. This shape is actually congruent to the tangent graph. It's the same shape. It's just oriented a little differently. It's in a little different position. It's kind of this mirror image. So what are we learning about the cotangent graph? Well, its asymptotes are wherever, okay, the tangent was 0. And then it has this kind of sort of flipped look. It's kind of a flip over. If I was to kind of maybe take this thing and flip it over, okay, take this image and flip it over, I would get this look right here. And so that would be the cotangent graph. So again, this has a period of 180 degrees, just like the tangent graph has a period or cycle of 180 degrees. It looks like it's kind of going in the opposite direction, and it's also, whereas tangent was kind of centered on the origin, cotangent seems to be centered 90 degrees to the right at 90. So they're centered a little differently. And those seem to be the main characteristics. So that's the technique of graphing by using the idea of reciprocals. Now, of course, when things start getting more complicated, like y equals 4 plus 3 cotangent 2 theta minus 60 degrees, now we start throwing more transformations at you. It starts to get be kind of a challenge. This is what we're going to work on in class today, is kind of showing you how to kind of take this, but the key first step is understanding sort of the reciprocal idea. So we're going to do more of this in class right now. Thanks for watching.